All right, so the next thing that we really need to talk about in terms of electrons and atoms, and there is still a significant amount more that we need to talk about because it is such a important chapter, is what we call Heisenberg's uncertainty principle. Heisenberg was a German scientist, and what his uncertainty principle says is this: the position and momentum of a moving object is uncertain. And really what that basically says is this: electrons move randomly, okay? And since they move randomly, then as they're moving around the nucleus, we really can't, therefore, you can't really know where they are and or their speed. Okay? So think about it this way. Let's say that we take a very accurate photo, snap, of an electron moving around the nucleus. So the electron, here's your nucleus, okay, positive center. Electron's kind of moving around. It might be there one time, and then the next time it's here, and it's moving around the nucleus. If we take a snapshot, then sure, we know where it is. We know kind of where it is. But at that moment that we take the picture, it's now gone. So because they move random, even if it's not random, even if it's a straight line, let's say something is moving in a straight line, if I took a picture of where it is at a certain point, it may be gone. So if you know one, either the movement or the position more accurately than the other, then the other one might be more of a guess. So that's what basically Heisenberg's uncertainty principle said, is we're just uncertain where things might be. So I put a picture up of Heisenberg, and again, this is from his uncertainty paper, 1927. And this is right around the time, just after Einstein doing a lot of his research and whatnot. The more precisely the position is determined, again, that would be like a snapshot of a photo. The more precisely it's determined, the less precisely the momentum. Again, and I say this is, if we took a picture of an electron, wouldn't that be a good picture of it? Yeah. Which way is that moving? We can't tell because it's such a certain picture. Is it moving this way? Could it have been moving that way? Could it have been moving this way? This way? Could it have been moving, I guess, towards you? Nice big arrow here coming at you. By looking at just the electron here in a snapshot, by knowing the position, we don't know the momentum. Okay? Or if you do know the momentum, we know it's moving, we see something moving, here it is, here it is, here it is. We don't know the position as well. So that's what basic, and it's an important theory. We don't really know exactly where electrons are, especially, but because they are, it's their position and momentum is moving. Okay? A couple of little jokes here. Heisenberg is out for a drive when he's stopped by a traffic cop. The cop says, "Do you know how fast you were going?" Heisenberg says, "No, but I know where I am." You've perhaps seen or heard of old inns that have plaques on the wall of a room saying, for example, George Washington slept here. Well, there's apparently an inn in Germany with their own plaque. It says, Heisenberg may have slept here. Uncertainty. Okay. So moving right along. Probability in orbitals. We use this uncertainty principle to deal with the probability of where an electron might be. Okay? So again, when you think of what the definition of probability is, it's the likelihood that something may happen. The probability that you are going to see the sun rise tomorrow is pretty good. It's the likelihood is pretty good. The probability that the sky turns blood red tomorrow, probably 0%. You're talking, maybe you go a little bit higher, but probability, the likelihood that something may happen. It deals with statistics. You can talk about probability and take courses on such. But basically, when we're talking about probability, the reason is because of Heisenberg's uncertainty principle. So it is important to recognize that electrons are located in the third dimension. Okay, electrons are located in the third dimension, and that probability is going to allow for what we call those orbitals, which are regions where electrons are likely to be found. So an orbital is a region where an electron is likely to be found. Okay, so third dimension is important. Let me draw 3 dimensions here. We've got our x, our y, and the z-axis. Remember, the z-axis would be coming in and out of you. It's not going on a diagonal. It's the third dimension, in and out. Okay. Now, if I put a dot representing an electron, so dot represents electron. Okay. Only one. Meaning, so here's an electron. There's a picture of it. It moves around, and then it's here, and then here, and then here, and then here. And so we keep taking snapshots of the exact same electron. Okay? And it's located every time we take it. So this is the same electron. Okay? But we've taken, I don't know, 50 snapshots of it. Okay? You may have something that looks like this. There might be an outlier somewhere, but basically looks like this. This region where the electron is likely to be found is pretty apparent. Doesn't it look like it would be basically in that region right there? The likelihood, the probability that it's found in that region is very good, and the region we call an orbital. So this region, again, that's just one electron taken of a whole bunch of photos, is the orbital. So electrons do not move around in orbits around your nucleus. Let's say you have your nucleus in the middle. It's not just going around in orbit, but that region around. That's where kind of people may have heard the cloud around it. And I'm not a big fan of cloud because, again, you could have just one electron, but rather the region, which of course by definition is your orbital. Let's stop right there, and we're going to move on in orbitals in the next little piece.